Alright, welcome to our third unit in calculus. In this unit we're going to explore the derivative, which is the driving force behind really all of calculus, but especially this first semester. Second semester we'll take a look at the integral, which is the inverse operation with the derivative. So we got a couple of things that we need to point out. This first section involves tangent lines and some rates of change and some different things that are related to the derivative. What I had you watch with the Khan Academy video was a little introduction of what it really is, and you saw that Usain Bolt can run roughly 30 miles per hour. Pretty incredible. Rectilinear motion is when you have an object that travel in a line. And that's a concept that will come back throughout this semester that you just need to understand what that word means. It's not really all that important in terms of derivative, but you're going to see it quite a bit, so I just didn't want that to confuse you too much. Our first real concept is average rate of change. And the average rate of change is, as the Khan Academy pointed out, the slope of a line that connects 2 points on the graph, what we call the secant line. So if I have a point over here and I call that point A, and I have a point over here and I call that point B, and I draw this line in, this dotted line in here, I call that line the secant line. And if you find the slope of that secant line, which would be the change of the y values minus the change of, over the change of the x values, you would find that that's the average rate of change between A and B. And what we want to do in this section, or what we want to do in this unit, is we're going to close in right at A or right at B, and we're going to make that delta x, or that x2 minus x1, we're going to make that really, really, really small. We're going to find out what's happening right at A. And that's what he's trying to point out with Usain Bolt, that if you were to take a flash, right at a given second, how fast is he running? It's like if you go through the speed cameras over by Pyle, and it flashes in your rear view mirror, you're traveling too fast, and so it took what's happening right at that instant, and that's what we're going to take a look at with our derivative. One of the things about derivatives that you need to know, some derivative notation, and I'm going to get a lot into the shortcuts of derivatives over the next few videos, but what we're going to do is we're going to talk about the definition. If you have a function f of x, we write f prime of x means the derivative. We'll talk more about derivative notation a little bit later on. It's the limit as h approaches 0 of that difference quotient that we worked with. So it's f of x plus h minus f of x over h. And use algebraic. For now, you have to algebraically work it out. A couple videos you won't have to, but right now you will have to. So if I were to say, okay, f of x equals x squared, find f prime of x, which is a function related to it, the derivative of it, you'd set up the limit as h approaches 0 of x plus h squared minus x squared over h. Square out that binomial, you get x squared plus 2xh plus h squared minus x squared over h. The x squares will subtract out. I can divide both of these by h, so I take the limit as h approaches 0 of 2x plus h. Now I can let h be 0, and you find that limit is just 2x. So that means the derivative of x squared is always 2x. And when you learn shortcuts down the road, you'll find, and that will be an easy one, that's just a little power rule, so that's what you'll find that is going to be. A second thing with derivatives is that the derivative is three concepts we look at. Number one, it is the slope of the line tangent to a function f of x at x. So let's choose a point on my previous graph. Let's say we choose the point 2, 4. That's on x squared. If I wanted to write the equation of the line tangent to the graph at 2, 4, in other words, I were to draw, let's say I drew an x squared again, and I drew, let's say that point right there is 2, 4, and I drew a tangent line to that graph, something like that. I want to know what the equation of that line is. So what I know is that point is 2, 4. If I were to plug it in the derivative, f prime of x, that is the slope of that tangent line. So 2 times 2 is 4. So now I'm point slope 4, and I can write the equation of that line. The equation of that line is y minus 4 equals 4 times x minus 2. The second thing the derivative is the velocity of a particle. And that's the instantaneous velocity, or just velocity in general. So if I'm just taking a look at Usain Bolt again, roughly 30 miles an hour, that's what he's running. If they ask you about average velocity, sometimes written as this, that's simply the distance divided by time. So like if you're looking at average velocity traveling to Baltimore, and Baltimore's 50 miles away and it takes you an hour, your average velocity is 50 miles an hour. And the final thing that the derivative is the instantaneous rate of change. And we can ask you, or the AP folks, or I can ask you on a test, the derivative any one of these ways. So I could ask you velocity, instantaneous rate of change, slope of tangent lines, equation of tangent lines. Those are all concepts that you'll see, on test and on quizzes and all that stuff. And then also, not only that, but you'll see it on the AP exam. Let me do another example for you on velocity. Let's say we give you a position function. And again, this is when things are moving in like rectilinear motion. Oh, sorry. Trying to erase. There we go. Okay. Let's say I want to find the velocity. And I give you a position function, s of t is the square root of t. Okay. The velocity of t, or the velocity of the particle at t, is the derivative of s. You'll find a little bit later on the acceleration is going to be the derivative of the velocity, and you can just keep on taking derivatives, higher order derivatives. So if I want to take this is going to be a little bit more of a challenge algebraically. What I'm going to do is I'm going to say, okay, well, the velocity is going to be the limit as h approaches 0 of the square root of t plus h minus the square root of t over h. Obviously, I cannot allow h go to 0 because then I'd have division by 0, and I can't do that. Remember from our limit stuff, we want to multiply this. As soon as you see the square roots, you want to think, I want to multiply by conjugates. So I'm going to multiply by the square root of t plus h plus the square root of t over the same thing. When I multiply that out, I want to FOIL out the top part. That's going to, remember, because it's conjugates, I just have to go first times first and last times last. I still have that limit as h approaches 0. It's going to be t plus h minus t over h from here times the square root of t plus h plus the square root of t. And the t's will cancel. They'll subtract each other out. And then the h's divide out. And so I'm left with a 1 on top. So I have 1 over the square root of t plus h plus the square root of t. I can now let h go to 0, and I get the square root of t plus the square root of t. So the velocity function is going to be 1 over 2 square root of t. And if I had a t value, that's a square root. That's a really bad square root. Let me try to tighten that up. I have 1 over 2 square root of t. It's hard to write on this thing. If I had a value for t, like let's say I had t equals 9 seconds, something like that, at t equals 9, the velocity would be 1 over 2 times 3, or 1/6. And that would be the velocity at 9. All right, so algebraically, you're going to have to deal with some of the derivative stuff in this first section. We get into shortcuts very, very quickly, and when we get into shortcuts, it'll be helpful for you to refer to the front page in your book, and I'll post the derivative shortcuts up on the website and all that stuff. That's really what you want to learn. They sometimes will ask you about the definition. One question on the AP exam maybe about the definition, but for the most part, we deal with the shortcuts. Good luck.